Optimisation. The height of a roller coaster is given by this function. Cubic. Positive cubic. Going to look something like that. We know if we're asked to find the maximum and minimum height of this roller coaster, this maximum and that minimum both happen at stationary points. So we're going to go max, minimum at stationary point. Therefore, find h dash. H dash is, just by rule, x squared minus 6x plus 8. But we're then going to say that the interesting thing about these stationary points is stationary points where the gradient is 0. Therefore, we're going to set, that's a therefore, h dash equal to 0. So see this h dash? We're going to set it to 0. Because these stationary points happen where the gradient of the slope is 0 and h dash is the gradient of h. Okay, where that's h and that's x. Oh, awesome. The factors of 8, let's do this manually. The factors of 8, 1, 8, 2, 4. Because we've got a negative here, 2, 4. They're either both negative or both positive because we've got a positive here. What adds to get negative 6? Minus 2 minus 4. So we're going to go 0 equals, let's do it the other way. So x minus 2, x minus 4 equals 0. And by my null factor law, then x will equal 2 or 4. So we know that that's the point 4, and that's the point 2 or 4. So if the question said where did the maximum and minimums happen, we would say they happen where x equals 2 or 4. Potentially, they will say what is the height. If that's the case, you're going to go the height when x is 2, and you're going to sub straight into the function that says height. So we're going to go 1/3 of 2 cubed minus 3 times 2 squared plus 8 times 2 plus 2. And we're going to whack that in the calculator and just get an answer there. And then we're going to get the height of 4 exactly the same way. Let's not worry about that now. You can do that in your calculator. Importantly, again, because I'm running out of room, I'm going to get rid of that because I've got the information here. Potentially, it might say, confirm which point is the maximum and which point is the minimum. There are two ways, isn't there? One is graphically. So we've already graphically justified why the 2 is a maximum and the 4 is a minimum. However, to do it mathematically, determine nature of stationary point, we're going to use the second derivative. So we're looking at h dash dash. We're going to do that by rule as well. So that'll be 2x minus 6. So we're going to find whether 2 is a maximum or minimum. Seems a bit silly with this graph because we do know that it's a maximum, but in future we're going to have some weird looking functions here that we're not going to be able to visually see that easily, so we're going to need to use our maths. So we're going to say for the point x equals 2, h double dash of 2, we're going to put the 2 where the x is, 2 times 2 minus 6. 2 2's are 4 minus 6. Now technically I really don't care what the answer is. I'm going to say that it's negative. Negative means that you can even put your unhappy face in there. Because it's a negative, I'm unhappy, therefore it's a maximum. just squeeze that one in. So that's mathematically proof that where x is 2, this function has a maximum value because the second derivative is negative. And where x equals 4, we get 2 times 4 minus 6. 2 4s are 8 minus 6. Positive, we get a smile. Smile has a minimum. So that's our mathematical justification that the 2 is a maximum and the 4 is a minimum. Okay?